All right, boys and girls, welcome back to a nice little calm day after the Super Bowl version of the drive-thru. Hungry? Stop by the drive-thru. Stop by the deli and get yourself a random fact of the day. Like, did you know that this weekend the first ever recorded death due to meteorite occurred in India? Poor guy. Never saw it coming. Okay? Literally. All right. So, in addition to fun facts, we will be talking today about spatial right triangles. And so that makes sense that we're doing this right after special right triangles. All these are right triangles that exist in 3 dimensions. So we're just going to do 2 examples and let you know that this is absolutely nothing different than what you've already been doing. This video just gives you a couple of examples with a bad joke or 2. So find the diagonal of a box whose sides are 3, 5, and 7 inches long. Hopefully this kind of looks familiar because I think when we started this section, or when we started right triangles, we had a question like this. Okay? It doesn't really matter what you decide to title, okay? As long as you can understand that you got that. Here, this will help. What we're trying to find is that red line. Okay? Now hopefully you can observe that this is still a right triangle. So if I redrew this 3-dimensional triangle in 2 dimensions, it would look like this. Sorry. Okay? Hopefully we can see that that is 7. But how long is the blue box, or the blue diagonal? Well, look at this aerial picture of the blue diagonal. So this is 3, and this is 5. So the blue diagonal will be the square root of 25 plus 9. And that's just going to be radical 34. That's going to be as good as we can do for that one. Okay, so now we know that the blue diagonal is radical 34. So the red hypotenuse, which is the diagonal of the entire box, would be 7 squared plus radical 34 squared is h squared. So you got 49 plus, these just cancel each other, they're inverse operations. So you get, 50 plus 33, you get radical 83 is how long that diagonal of the box is. Okay, and radical 83 is simplified. Okay, example 2. Your pet ant wants to climb up the square pyramid that you built. Of course, everyone's building square pyramids these days. It's the rage. Your square pyramid has a base of 100 square inches and a height of 10 inches. So let's Widmapoi here. So a square pyramid has a base, a base that's a square. So if I drew, that would look like this. So if I drew an aerial version, if this area is 100 square inches, what does that tell us about the side lengths of our square? Okay, good. They're each 10. Now, is every route that you're, let's go over, sorry, one more thing. Now it says the height of the pyramid is also 10. So there you have that. Now, is every route that your ant takes up the pyramid going to have the same length? It's not. Do you know what route is the shortest? You think this one's the shortest? Yeah, they can't. Your ant cannot walk up the altitude. Good. So where is that? Where is that slant height? It would be the altitude of that triangle that's leaning over, right? Okay, so here is our right triangle. Now again, let's redraw this right triangle. This is 10, and what is this right here? That's 5. Okay? So don't call this 5 radical 3. That's a common mistake that kids will make because we just did that section. This is not a 30, 60, 90 triangle. So just say h squared equals 10 squared plus 5 squared. So h squared is 125. So h is 5 radical 5. So what is the shortest possible root? It's this root, and the shortest possible distance is 5 radical 5 inches. Can I get a boom? Thank you.